Lesson 9 is creating linear equations from graphs, and in 9.1, we're just going to interpret a few graphs. So we're going to try to find and interpret the rate of change, which remember that just means slope, and then also interpret the y-intercept. So just as a reminder, rate of change, that is the same thing as slope. And then there's a couple different approaches that we can take to finding the slope. So we need to find it and then we can go ahead and interpret it. Interpret it means explain what it means in the context of this problem. So one way is we can think of slope, which the variable we use for slope is m. We can think of it as a rise over a run. And then we just need to find 2 points that are on our graph, and we want to find exact points. We don't want halfway points or anything like that. So on my graph, I'm going to use this point right here, which it looks like the y-axis is scaled by 10s because it's 10, 20, 30, 40. So this being between 60 and 80, that would be a 70. And then the other point I'm going to use is right here. So that point is at 2 on the x-axis and it's at 90 on the y-axis. So now I need to figure out my rise between the 2 points. So how far am I going up to get from one point to the other? I'm going up 2 marks on the y-axis. So that would mean that my rise is 20 because I went up 20. And then for my run, it's how far am I going left or right? So I'm going to the right over to 2 on the x-axis. So I'm going 2 right. So my run would be 2 to the right. And you don't actually have to put the arrows out there. I was just kind of showing what direction we're going. So we had to go up 20 and then over 2. And you just always want to make sure that when you're finding your rise over run, you're paying attention to the scaling. Like if I had just counted the marks on the graph itself, that would have been up 2 over 4, but we have to pay attention to how the graph is scaled when we're finding our rate of change. And then if we want to, or if we can reduce it, we want to. So 20 over 2, that's 20 divided by 2, so that's 10. And for now, just when we're interpreting it, I'm going to leave it as a fraction, so I'm going to think of it as 10 over 1 because that'll help us in a little bit. So the other option for finding slope, which is the one that we typically use when we're just given points, when we don't have a graph in front of us, but you can use it here, so I just want to compare to it, is when we use that slope formula. So it's m equals y1 minus y2 equals over x1 minus x2. And then we just need to pick any 2 points from our graph. So this point right here, where we're at the y-axis, that was at 0, 70. So I'm going to just go ahead and use those 2 points because I already have them, but I'm going to make this my x1, y1, and then this is going to be my x2, y2, just so I'm subtracting the smaller numbers. So my y1 is going to be 90 minus y2 is 70. Right, because these are my y's, and then these are my x's, the first coordinate. So in the denominator, my x1 is 2, and then my x2 is 0, so minus 0. So it was y1, 90, minus y2, 70, x1, 2, minus x2, 0. And then now I can go ahead and simplify. So 90 minus 70 is 20 over 2 from 2 minus 0, and then 20 over 2, that's going to simplify the same way, so 10 over 1. So we found the slope. It's 10 or 10 over 1, however you want to read it. We haven't interpreted it. Sorry, it's hard to say. We have not made the interpretation though yet. So think about interpreting, if you have an interpreter, it's something that's translating something to you in a language that you understand better. So we are going to interpret this slope 10 in the context of this problem. So another way that we've talked about slope before is the change in y over the change in x. So change in Y, if you look at the way that the Y-axis is labeled, is the monthly cost. So that's how my Y is changing, because that's how my Y-axis is labeled. And then for change in X, if you look at the X-axis, it's data used. So monthly cost over data used. So all we really have to do to kind of like interpret our slope and make it in the context of this problem is if we know that slope is change in Y over change in X, and we put our like Y axis, the way it's labeled, in the like numerator with the Y. So it'd be like a $10 monthly cost over our change in X, so over data used. Now we can kind of start to make sense of this. So our change is $10 per 1 GB of data used. So like every time we go up by a data up by a gigabyte of data, our monthly cost increases by $10. So kind of like with word problems where you like write your final answer in a sentence, that's what we want to do here. So I'm going to give myself a little bit more room. But one more time, since we got that our slope was 10 over 1, 10 is like the amount that our monthly bill is changing each month. And then the 1, the change in X, is how much gigabytes we're using. And this information is coming from the way that the axes are labeled. So that's why it's so important to have them labeled. So we can say, you can write it whichever way you want as long as you're explaining the situation. But I'm going to write it as each gigabyte costs $10. So each gigabyte costs $10. You could write it as like using an extra gigabyte would cost you an extra $10. However you want to write it, that puts that information together of that there's a $10 increase per each gigabyte that you use. Okay, and then for interpreting the y-intercept, I think this is the easiest part or easier part of this type of problem. So the y-intercept is where our line crosses the y-axis. So we already found it. We used that point. It's at that 70 because that's where it hits the y-axis is at 70. So the variable that we use for y-intercept is b. So I can say b is 70. And think about that's where our graph is starting. So that's kind of like our baseline for our monthly cell phone bill because that's where it's starting. And then after that, of course, if we use an extra gigabyte, it's going to go up by $10. If we use 2 GB, it would go up by $20 and so on. So that 70 that we're starting at is like the starting price of our bill. So $70 you can say is the starting price, is the baseline, but however, like you want to word it, we just need to know that that's what the minimum value of our bill is going to be, and then it'll go up from there based on how much data we use. So $70 is the minimum charge on our bill. Okay, so the cool part is, I mean, maybe not cool isn't the right word, but the nice thing is that the like slope and the y-intercept, they're going to keep the same relationship for like all linear functions, every single graph that kind of falls on like a straight line. So the slope is how much we're increasing or decreasing by each month. In this case, it would be increasing by 10 and then per gigabyte. And then the y-intercept is always the starting value. So in this case, our y-intercept is 70. That's like the starting value of our bill. That is the lowest it will be. And then the next little question from this section, if someone purchased the plan and used 3 GB of data, how much would their cost be that month? So if that's the case, if you notice on the x-axis, that's our data used in gigabytes. So we would just need to go to where 3 would be on the x-axis, and we need to find that point. So we would go up from 3, and that point is right here. So we would need to find the y value that goes with that point, which is 100. So this point is 3, 100. So that means that if we use 3 gigabytes of data, we would pay $100. Okay, 9.2, so determining slope-intercept form, which remember that slope-intercept form is y equals mx plus b. So a formula for a slope-intercept form. So starting at the top, depreciation is the decrease of an item's value over time. So when something loses value, we call that depreciation. The following graph shows the depreciation value of a car. So interpret the slope in the y-intercept just like we did in 9.1, and then write the equation of the line in slope-intercept form. So in order to write the equation of the line, we need to find m and we need to find b. So m is our slope. So we're going to find it and then interpret what it means in this context. So we can find it in the same way that we found it before. We need to pick any 2 points on the graph. So I'm going to pick this point right here, and then I'm going to pick this point right here. And then we need to find our rise over run. So to get from one point to the other, I have to go down this far. So I'm going from 1,000, or not 1,000, sorry, 12,000. I'm going down to 8,000. So I'm going down, or like a negative 4,000. And you could always find that by like subtracting 12,000 minus 8,000. And since we're going down, it would be negative. And then my run, hold on, I'm going to add that to the rise. So I'm going down 4,000. So my rise would be negative 4,000. And then my run is how far over I have to go. So I'm going to the right. I'm starting at 0 and then going to the right 2. So my run would be 2. And notice that like I went to the right, so it's a positive 2, but still naturally like I'm going to end up with a negative slope. So if I simplify this, negative 4,000 over 2 is going to become negative 2,000, or I can write it as negative 2,000 over 1. I'm going to do that just for like the interpreting purposes. I want to show you how if you switch your starting point, you may end up with like not a different answer, but a slightly different like middle step. So let's say I started with this point right here, and I'm like, okay, well, to get from this point to this point, I actually have to go up 4,000. So it would be a positive 4,000, but then I have to go left 2. So going left 2, that would make my run a negative 2. So this would be 4,000 over negative 2, which that still simplifies to negative 2,000. Okay, so you just have to make sure that if you're going up, that's positive, down would be negative for the rise, and then for the run, right is positive and left is negative, just kind of like if you had a number line, like if this is 0, 1, 2, the positive numbers go to the right and the negative numbers go to the left as you get smaller. Okay, I'm just going to erase the rest of this clutter, and then now we'll go ahead and interpret what this means. So in order to interpret, we have to look at the way the axes are labeled. So keeping in mind that the numerator is the change in y, so I'll take my y value, like, or I guess the way that the y-axis is scaled is going to go along with the numerator. And then the denominator is the change in x. So they all, I know I've kind of like said the slope formula in a bunch of different ways, but they all have the same meaning. They're just written a little bit differently. So like rise is the change in y. because it's like how far we're going up and down, and the y coordinate is controlling how far we go up or down. The run is the change in x because the x coordinate controls how far left or right we go. Okay, so if my change in y is 2,000, my y-axis says that the value of the car in dollars is represented by a y. And then my change in x is 1, and then x, or the x-axis, is labeled as years since purchased. So if we put those two together in context, that means that the car's value depreciates $2,000 per year. So you wouldn't say like it depreciates negative $2,000 because depreciates, like that word means that it's going down in value, so that covers the negative. So for our interpretation, we can say the car depreciates by $2,000 each year. Okay, so this is my down $2,000 per 1 year. And then for the y-intercept, I'm just going to make a note over here too that we simplified our m to negative 2,000 because that's going to help us once we go to write our equation. And then for our y-intercept, we need to interpret that as well. That's just the point where the line hits the y-axis. So we found that point right here. It's 0, 12,000. So that's the starting point of my line. Since the y-axis is the value of the car, that means that the value of the car is starting at 12,000. So for y-intercept, we would say b, that's the variable we use to represent y-intercept. Remember, slope is m, y-intercept is b. So b is 12,000. And then we can say that that's the initial value of the car, or we can say that the car was purchased for $12,000. However you want to word it is fine. So car was purchased for $12,000. So the part that I have highlighted in blue, that's the interpretation part. So us explaining what it means in the context of the problem is what it means to interpret. And then now we need to go ahead and write our equation itself. So I'm going to go back to the formula. So the formula is y equals mx plus b. That's for slope-intercept form. And then we already know m. We found that right here. And then we already know b. That was 12,000. So I just need to take both of those and substitute them into the formula. I don't put anything in for x and y. Those just stay the same. So I'll put negative 2,000 is going to go in for m. So it's y equals negative 2,000 x, and then 12,000 is going to go in for b, so plus 12,000. So y equals negative 2,000 x plus 12,000 is the line, or is the equation that represents this line. Okay, 9.3, so this is determining point slope form, which is just a different formula. It's just a different form the lines can come in. So that formula was y minus y1 equals m times x minus x1. So starting from right here, Carla earns a commission-based salary working at a furniture store. She wants to write an equation to help a coworker with the same salary calculate his earnings based on the number of items that he sells. The following graph models her earnings based on the number of items that she sells. Write the equation in point slope form. So we just want to be able to get to the point where we can write an equation in point slope form. I'm going to rewrite the formula down here, just so we can talk about the different things that we need to find. So in general, when you're writing an equation, y and y and x, those are part of the equation. Like those will be in your final answer. So that means that the other pieces of information that we need to find are y1 and x1 and then m. So it's the same m that we've been finding like all throughout these notes. So I'm going to start with that. So I just need to pick 2 points on the graph. So let's say this one right here, and then this one right here. So to find m, we're finding rise over run. So to get from one point to the other, I'm going up from 50 to 150. So each like tick mark on the graph is 100. So it looks like I'm going up 100. So my rise will be 100. And then my run, I'm going over from 0 to 20. So, and I'm like saying 0 on the x to 20 on the x. So my run is 20. And then if you can simplify, you should. This one doesn't ask us to interpret, so I'm not going to worry about leaving it as a fraction because when I go to put it in the equation, I'm not going to leave it as a fraction. So 100 over 20 is 5, and it's not wrong if you put 5 over 1. Just usually when we make the equation, we want it to be more simplified. Like that's what we did up here. Instead of putting negative 2,000 over 1 into the equation, we just put negative 2,000. The fraction just really helps for interpreting and if you had to graph it yourself. Okay, so m is 5. So we found m. And then x1 and y1 just come from a point, any point, like literally any point on the graph. So for the sake of doing something different, I'm gonna pick a different point than the ones we already like used, but you could use those same ones. That blue point that I just put on the graph is 40 on the x and then 250 on the y. So that's going to be my x1 is 4, and then my y1 is 250. So I just have to put my y1 250 in there, and then my x1 in here. So altogether it would be y minus y1, which is 250, equals m, so we found that over here, that was 5, so equals 5 times x. Remember the regular x is just staying the same, just kind of like the regular y stayed the same, but for x1 I have to put in 4, so minus 4. And then this is endpoint slope form, so we don't do any simplifying beyond this, we just leave it as is. So it's y minus 250 equals 5 times x minus 4. So because you can pick any point for your equation, there's technically a lot of different ways that you could write this and still get the correct answer, and that's perfectly fine. It's just one of the things that comes with point slope form.